Hello everyone. The topic of our team is neo4j. I'm Tao, and I'm gonna introduce you to neo4j and talk about the storage and the index of neo4j. Suchit will continue to talk about cipher, advantage, and make a conclusion. And she will play a demo and introduce you to our application. neo4j is a high-performance database, and it is one of the most famous not only cycle database, and because of its graphical structure, it can handle complicated relations in data. So it is widely used in financial application, social applications, and recommendation system. And it is written by Java and Scala, and the software is open source. Now let's talk about the storage of neo4j. There are three basic elements in neo4j's graphical structure: node, relationship, and property. They are corresponding to vertex, edge, and the information on them. Here in the right is an example of neo4j's graphical structure. We can see two nodes here and a relation between them. The property of this node is the name property of this node is Tom Hanks, and the property of the relationship is acted in. The name property of this node is Cloud Atlas. So it states a relation that Tom Hanks acted in Cloud Atlas, and by expanding the nodes and the relations and the connections between them, the database can grow up to a larger one. And because of this structure, neo4j can handle more complicated data than other databases. But in another side, the data size will be limited. Similar to relational database, we can create indexes in neo4j. The difference is that in relational database, we create index on index field of a table and maintain a pointer to the page of the row. While in neo4j, we create index on property of a certain label, and it will point to the node or the relationship. But what's in common is that both of them will speed up the seeking and increase the performance of the database. However, in neo4j, we have to be very careful selecting indexes, because a redundant copy of data will also be added to the storage space when we create a new index. So it's very important to choose what to index and what not to index. And once an index is created, the index will be automatically updated or deleted by the index manager of neo4j. And another property is that the indexes are not immediately available. It will be unsynchronized executed. So the system will take some time to create the indexes in the background. Well, we can create two kinds of indexes in neo4j. One is composite index, which is based on multiple properties, and another one is simple property index, and which is only based on one property. Well, composite index can only support equity check. Well, we can use single property index in multiple ways. For example, range comparison, list membership check, prefix search, suffix search, substring search, existence check, spatial distance research, and spatial bounding box searches. And in Cipher, there's no need to specify which indexes to use in query. And now, Suchit will continue to talk about the Cipher in neo4j.
Hey guys, so today we're going to talk about the Cipher query language, and I'm actually also going to talk about the advantages and disadvantages of using neo4j as your database. So let's jump into it, okay? Cipher query language. So Cipher query language is the query language used by neo4j in it. So the developers of the Cipher query language made it in such a way that it was very easy and intuitive to use, and they made the syntax also very similar to the SQL database syntax, so that people who are actually shifting from SQL database to neo4j won't have that much of a problem. And yeah, so they try to keep it very much similar. I mean, we'll just go through some examples so you will get an idea of what I'm talking about. I just want to talk about more about there is something called as the Open Cipher project. Okay, so what this project is all about is it is an open source project, and it is the regular Cipher language used by the Neo4j. But you could actually also modify the Cipher query language on your own. It is actually being developed currently as well by some developers, and it is continuously having some versions coming out with some more functionalities. So yeah, you could have a look at that. So let's just run into the examples. Okay, so the first example is for just creating a simple node. Okay, so yeah, I wanted to mention that the Cipher query language is actually case sensitive. Okay, so the first example says that create is the word for creating the node. Uh, Whenever you open up curly braces, whatever goes inside the curly braces are actually the properties of that node. Okay, you have a property of name and the value is Anna. Okay, can we we'll just go to the third example now. Okay, so create, yeah, you're just creating a node, and X is the identifier of that node. Okay, and you're labeling it as person, and then you open the curly braces and put all the properties into it. Okay, so it will make a node with identifier X and labeled as person with all the properties you give into it. So whenever you actually make these kind of nodes, okay, so if you see that every time you make a new node of the same type, it will show on a new screen. So if you want to retrieve all the nodes you've made on a single screen, okay, you can actually run the second example. Match X. The X is the identifier for a particular type of node, and return X. So basically, what it does is that it returns all the nodes of that identifier, right? Okay, so let's just jump into the fourth example. Retrieve all the nodes labeled as person having parameter from Poland. Okay, so match a y person. Y is the identifier, person is the label. Where y dot from, that is the property. Y dot from has the value Poland, and return y. So because you want to basically you're returning all the nodes which has the property that the person is from Poland. All right. Let's jump into the last example. We're just creating a relationship over here. Relationship is basically when there are like many various nodes, all right, and relationship is the relationship between those nodes. For example, a person, student, there are two entities. A person is a student, all right, so is a relationship. Yeah, so the syntax given there is for making the relationship between the nodes. Okay, let's go further. So as we can see that yeah, the first example of the query is the same. We had a talk about it. Then for deleting, you just write delete n. The n would be the identifier of those nodes, and you can see the further examples. I mean, you've kind of got an idea of about what I'm talking about. So let's talk about the algorithms used in Neo4j. So there are like various algorithms used. Let's just there are like centrality algorithms, community detection algorithms. I'll just give you like small gists about each of them. So centrality algorithm is basically it talks about every node and the importance of each node. All right. So it kind of works on similar ways of how a page rank works. It's something like that. You can see the pathfinding algorithm is basically our regular breadth first search, depth first search algorithms. They are basically trying to find the paths between the various nodes. And I mean, there are also various algorithms such as shortest path, where you try to find the shortest path between various nodes and something similar like that. All right. Hey guys, so let's talk about the advantages and applications of Neo4j. So the advantages of Neo4j would be that it is definitely way faster than the relational database. And the reason is because I mean, whenever the application gets very huge, which obviously every real life application gets with time. I mean, every application has various components. So if you want to query a particular thing in a relational database, I mean, as we know that we have to go through joins, all right, we have to join tables together, and then we have to look at the integrity of all the data in our tables, and we have to worry about all those things. But in Neo4j, the graphical database, the main thing is that we don't have to worry about all that. All the data is at one place. They are like various nodes and entities and relationships. So we don't have to worry about tables over here. And when you actually think it as a concept, I mean, this makes more sense. When you're actually going and talking about various scenarios and making applications on it, like just like social media, I mean, you wouldn't really expect that every person has a table for him. I mean, that would become very humongous of a task, and that wouldn't really be efficient as well. Querying on that database would be a very big pain. So I think the graph database really works very well and shines in these kind of situations, because the join operations take a very long time, as we also study about them. So we don't have to actually join using the graphical database. So yeah, it is very much faster compared to relational database. The second would be, I mean, it's very intuitive, and as we saw, the Cypher query language we talked about. When you actually go into bigger applications, the queries start getting very big. All right. So, and the main thing is, for writing queries in a relational database, I think you need to know a lot of things about your database. Like you got to know all the table names, all the integrities you have to maintain, and the attributes, and a lot of many things. In Neo4j, we don't have to know anything about table names. We just have to specify what we want and not worrying about how we're going to get it. That is also one very big advantage. The third one would be flexibility. Now, if we talk about a relational database again, whenever we are actually making an application, we have to plan ahead of the schema we have to maintain, like the tables and various things. In Neo4j, I mean, as it is a graph database, it is very easy to change the schema. I mean, if you want to add something, you just add another node and make relationships with that. You can change your application and the schema of the application very fast. The fourth would be optimization. The speed of the database operations do not decrease significantly as the database grows. That is how the database works. Even if the size increases, it doesn't actually lose on its performance. The main applications where the graph database are used in, the first one definitely goes in real-time recommendations. As we know, eBay actually uses Neo4j as its database. By using this Neo4j, it can actually recommend to customers they are buying and everything. So it will by using the various algorithms of similarities, it will actually suggest you all the products which you're more likely to be interested in. It is used in such applications. A graph database really works well in such applications. Social networking, an obvious one. We know that Facebook works on graphical database, LinkedIn works on graph database. So yeah, social networking and various applications like that. The third one is master data management. For example, take the university database. All right. Now we are students. We are obviously students. Okay. And but we could also be employees inside the university. Like we could be working as lab assistants, or maybe working at some dining service or something like that. So I mean, you just don't have one. You just don't belong to one entity. right? You're just not a student, you're also an employee. So if you're making a schema and you just expect that one person is going to be just a student, okay, and he's not going to be an employee, but he's also going to be in the employee table. So there are like very many duplicates in the database, and you have to take care of them, that they always remain in the consistent state and everything like that. So using graphical database, it is very much much more easier than the normal SQL database. I mean, you could just make various relationships without any problem. So yeah, it is used in such applications and maintaining the master data management. The fourth one would be the network and IT operations. I mean, there are like various networking applications and the network problems which are solved by graphical databases. Okay, so let's conclude this. All right. So we have seen the pros of the Neo4j, like high performance because of not actually have to go through joins and everything. We know that the design is very flexible, and there are real time updates possible on the graph database. I mean, there are actually like many applications and enterprises working on this using Neo4j, that they are actually utilizing the graph database to add all their businesses which are working currently, and all the updates are going on the fly, so they can actually make any decisions, and all the statistics of the market are very much maintained. And as we saw that visually also, the graph database looks very much appealing, and it makes more sense, and you would realize you would understand many more things other than just looking tables. There are three cons to using this. Okay, the first one is all data resides on a single machine. Now this one is a huge one. So for example, I mean, the database works in such a way that you cannot actually break it down into partitions. Like you break the tables down, you put one table somewhere and another table somewhere. That is not a problem. But in graphical database, you can't do that. It has to stay in one machine, and you have to access it from there. So for example, the storage could also be a problem in this scenario. So for example, you have your application database, and you didn't expect that the database was actually going to grow in size that faster, and you're running out of space in this scenario. Yeah, that would create a problem. So that's one disadvantage, that it has to be on one server and it cannot be partitioned into various part. Basically, you can divide it into various parts and put it in different places. That is the first one. The second one is the range and sorting queries are very expensive. As it is a graph database, the range and sorting queries are very expensive. So we generally try to not use it in applications where you need range queries and sorting very frequently. Uh, the third one is, as we know that this database works in a master slave way, all right. So the master node, we just have a single master node, and the slaves do all the operations for it. All right. So for example, if you have like a humongous number of writes, this could actually create a bottleneck, because all the slaves will require the master to give them all the work, and because of the huge number of writes coming in, it could actually create a bottleneck at the master node. I would conclude that we can definitely see the pros definitely outweigh the cons. So I think graph database is a good alternative, and we should definitely give it a shot.
Now let me introduce our application made by neo4j database. Our application is a movie database. You can search the information of the movies in our application, such as the movie name, year, actors, directors, genre, and the most interesting things that our application can recommend some related movie for you. As you know, the neo4j database save and record the content as the node and the relationship. So there are 4 types of node in our database. They are movie, actor, director, and genre. And there are also some relationships, and this relationship connect the nodes. So the relationships are act by, direct by, and jam. And each node has their own properties, such as the movie node has the name, year, budget, and score, and the actor and the director nodes has the first name and the last name. From this picture, you can see our data structure in the database, and the green circle is the movie node, and the red circle is the genre node, and the blue circle is the actor node, and the yellow circle is the director node. And between the different nodes, there are some relationship. You can see that the green node and the yellow nodes are connected by the direct by relation, and the green node and the actor node are connected by the act relationship. This is some examples of searching in our database. And this one is you can use the movie name to search the movie node. And you can see there is a where movie.name is equal to the Q. And we can get the movie node. From the movie node, you can get the information of the name, score, year, and budget. And the second example is that we can search the actors and the director belong to one movie. We also use the movie name to get the movie node first. And then we can start from the movie node and find the relationship of the act by. And then we can get the other side of the node is the actor node. So we can get there as the actor node. And this example is that we can search some special movie with the conditions, such as who is the director of the movie and what is the genre of the movie. And we can use both of the two limitations to get a search. Then we can get the special movie you want. And the last example is for the movie recommendation. And here we can search the movie node first. And you can see the second line is that we from this movie and search from 1 to 2 relationship to get another movie. And the relationship is the star. It means all the type of relationship we can use. Maybe these movies are directed by the same director, or maybe they have the same genre. Maybe they and if the relationship has the two step, it has the more complex to search. So I think this is the highlight of the neo4j database. If we search this in the other relationship database, it's very hard, and it will we need to join many tables together and search for a long time. And this is the picture of our demo application. We have a search bar, and you need to input the movie name, and we will search in the database to get all the information of the movie, and also we can do some recommendations for you to some similar movie. And this is our code. Um, for the database build, we use the Python, and first we clean our data, and then connect to the neo4j and create node and relationship, and then input this node and relationship into the database, and also set the connection between the nodes with the relationship. And this is our backend. Our backend was built with the Node.js, and we use the Express. So you can see here, when we get there are some APIs here. When the front end call the API to search the movie in our database, we will do a lot of search there, and include there are the cipher, and the first cipher is that search the node of the movie, and the second to the fourth cipher are used for search the movie actors, movie directors, and movie genres. And the last cipher is used for search the similar movie. Maybe they have some complex relationship, but our database can help you to search. After we get all of this, we can return this information to the front end. And this is our front end. And our front end is written by React. It's not very complex. It has one website, and I mean the one page. And you can see here, after I run the server and the backend and the front end, we can do some